Now we are going to learn about Nand-based RS Latch. Okay, so as we stated in the last video, we stated that in NOR-based RS Latch we used active high. So this should be active low because Nand is opposite. So here we have active low. That's the first point that you have to know. What is active low? Well, in active low, we consider that the input should be 0 for the given outputs to work. Okay, given outputs to work. What do I mean by this? Well, we have reset and set. Okay, we have reset and set inputs. When reset is equals to 0 and set is equals to 0 only, the RS latch that uses NAND gates, will work as expected. Or you can see that in another way. R bar should be equals to 1 and S bar should be equals to 1. It's the same thing. If R is equals to 0, then R bar is equals to 1. If S is equals to 0, that means S bar is equals to 1. But for easiness, for our convenience, we use R bar is equals to 1 and S bar is equals to 1. Okay, so here we are not going to spend much time. Okay, we'll just directly go to the truth table. Let's start with the truth table. So we have R bar and S bar, and then Q and then Q bar. Since we are working with R bar and S bar, we know if we use the table for R and S, okay, if you use the table for R and S, we know we start with 0, 0, 0, 1, 1, 0, 1, 1. Okay, this is the combinations. Since we are using the R bar and S bar, we should use the opposites of these. Okay, we should use the opposites of these. So we will get 1, 1, 1, 0, 0, 1, and then 0, 0. That's it. Okay, now since we have this, for NOR based system, we know here Q should be previous and then the Q bar should be previous. And here we know set is equals to 1 means Q is equals to 1, so Q bar is 0. And here reset means Q is equals to 0, so Q bar is equals to 1. And if these two are 1, 1, then the both output should be invalid, so it's forbidden. So similarly, it will work here also. For this is NOR based, this is NAND based. Okay, I'm comparing this so that you can easily understand. So if R bar and S bar are equals to 1, okay, R bar and S bar are equals to 1, then it will be previous. Okay, it will choose the previous state of Q or Q previous bar. Okay, that's the same thing. Since here actually S is going to work. Okay, actually S is going to work. The set is going to work. So Q will be 1, Q bar will be 0. Here reset is going to work. So it will be 0 and then 1, and this is invalid. Okay, invalid. This is the same thing. Now we are going to draw the NAND-based RS latch logic circuit. First of all, let's take a look at the equations that we have in our hands. First of all, we have Q is equals to S bar dot Q bar whole thing bar. Here Q is Q now, and Q bar is Q previous bar, exactly right before Q now. Okay, similarly we have Q bar is equals to R bar dot Q whole thing bar, where this Q is Q now, so Q bar will be Q now bar, and here this Q is Q previous. That's the idea. Okay, so we are working with S bar and R bar because we know NAND is active low logic circuits. So we'll put S bar here and then R bar here. S bar goes through a NAND gate and it is related to Q in this case, and then R bar goes through another NAND gate and it is related with Q bar, and Q will be sent through the NAND gate along with R bar, and Q bar will be sent through an AND gate along with S bar. And finally, we will have the RS latch by using only NAND gates. Okay, so this is how you have to draw the circuit for RS latch by using only NAND gates. So the first case, we have R bar is equals to 1 and S bar is equals to 1. The expected outcome is Q now is equals to Q previous, and Q now bar is equals to Q previous bar. That's the idea. Okay, so let's come up with the equation first. So we know Q is equals to, or Q now is equals to S bar into Q bar, Q previous bar, whole thing bar. So this can be given as S bar is 1. Okay, S bar is 1. So 1 into Q previous bar, whole thing bar. So that is Q bar, Q previous double bar. So that is equals to Q previous. Okay. Similarly, here we have Q now bar, that is equals to R bar into Q previous whole thing bar, and we know R bar is equals to 1. So 1 into Q previous whole thing bar. So that is Q previous whole thing bar. So Q now whole thing bar will be equals to Q previous whole thing bar. That's the idea. Okay. And the expected output is achieved. Now we can go to the second combinations where R bar is equals to 1 and S bar is equals to 0. Before I teach you this, okay, I'm going to teach you something called the Nand gate short circuit. Okay, if there are only two variables involved, okay, A dot B whole thing bar, we know if A is equals to 0, then without even considering B, we can say X is equals to 1. Similarly, if B is equals to 0, without even considering A, we can say X is equals to 1. How does that work? Well, let's say A is equals to 0. So X is equals to 0 dot B whole thing bar, and that is 0 bar, and that is 1. Similarly, B is equals to 0 means, okay, if B is equals to 0, X is equals to A dot 0 whole thing bar, that is 0 bar, so that is equals to 1. So even if one of them is equals to 0, even if one of the inputs for an AND gate is equals to 0, then the output will be equals to 1. That's the idea. Okay, so similarly, it's going to be here also. Since we hear S bar is equals to 0, well, first of all, let's come up with the expected outcome. We know since this is set, okay, Q now should be equals to 1 and Q now bar should be equals to 0. Okay, that's what we are expecting. So first of all, we'll use the one with S bar in the equation, which is Q now. So Q now is equals to S bar into Q previous bar whole thing bar, and we know S bar is equals to 0, so this is equals to 1. Q now is equals to 1. I'm applying this knowledge. Since Q now is equals to 1, okay, Q now is equals to 1, we can say from this I can derive Q now bar is equals to 0. And the expected outcome is satisfied. The expected outcome is satisfied. Okay, expected outcome is satisfied. Similarly, we can go to the third instance or third combination where R bar is equals to 0 and S bar is equals to 1. The expected outcome is Q now is equals to 0. Why? This is reset. This is reset. Q now is equals to 0. Q now is equals to 0 because this is reset. So Q now bar will be 1. Okay, so we'll start with Q now bar, okay, or Q bar. So that is equals to R bar into Q whole thing bar. Here Q is Q previous, and that is 0 dot Q whole thing bar. So that will be 1. Okay, that will be 1. So since Q now whole thing bar is equals to 1, I can say Q now is equals to 0. Expected outcome is achieved. And for the fourth one, we have R bar is equals to 0, S bar is equals to 0. Now this is a problem because the expected outcome is it is forbidden. Okay, it should be forbidden. How does that work? Well, we can say Q now is equals to S bar into Q previous bar whole thing bar. And we know since S bar is equals to 0, Q now will be equals to 1. Based on that, I have to say Q now whole thing bar should be equals to 0. But then if I find the equation for Q now bar, well then that's a different story because R bar Q previous whole thing bar R bar is equals to 0. So Q now whole thing bar is also equals to 1, which implies Q now is equals to 0. Now that's a problem. That's a contradiction. Since there is a contradiction, we can't actually allow this to happen. So this is forbidden. We have completed RS Latch completely. That's it. We have completed the RS Latch. Now let's go through the summary of these two latches, NOR based latches, and then the NOR based RS latches, and then the NAND based RS latches. So let me put a table for you first. First feature will be the circuit diagram. Okay, first feature will be the circuit diagram. For NOR based RS latch, it's straightforward. You have R and then you have S. Okay, and then you have to send it through a NOR gate. Here you will have Q. Similarly, here you have the S and then the NOR gate, and here you will have Q bar, and you will send Q through NOR gate along with S, and then you will send Q bar through a NOR gate along with R. Okay, that's it. NAND RS latch is a little bit different. Okay, NAND RS latch is a little bit different because you have R bar here, S bar here, and you will have NAND gates. That's also not a problem. Okay, you will have NAND gates, so you will have R bar here and NAND gate here, but instead of Q here, you will have Q bar. Okay, similarly here you have a NAND gate and S bar. Here you will have Q, and Q will be sent through along with R bar. Okay, oh no, here, from here you will send it through here. Okay, and similarly Q bar will be sent through this. Okay, that's it. That's the important one. Why? Well, we come up with the equation. Okay, we come up with the equation. Equation says that Q is equals to Q is equals to R plus Q bar whole thing bar, and Q bar is equals to S plus Q whole thing bar, and here Q is equals to S bar plus Q bar S bar dot Q bar whole thing bar, and Q bar is equals to R bar dot Q whole thing bar. That's the idea. Okay, that's the idea. Now, what's the next step? Well, the next step will be we have to understand the input type. Input type. Okay, we know NOR based RS latch will use active high, and then the NAND based RS latch will use active low. And then we have the hold condition or no change condition. For hold condition, S is equals to 0. Well, let's start with R. R is equals to 0 and S is equals to 0. Here, R bar is equals to 1 and S bar is equals to 1. Similarly, we have the forbidden condition. Okay, forbidden operation or invalid operation, where R is equals to 1 and S is equals to 1. Here, R bar is equals to 0 and S bar is equals to 0. For set condition, we know R is equals to 0 and S is equals to 1. And here, R is equals to 1, R bar is equals to 1 and S bar is equals to 0. Finally, we have the reset condition, where R is equals to 1 and S is equals to 0. Similarly, R bar is equals to 0, S bar is equals to 1. Pretty straightforward. Okay, pretty straightforward. This is the summary that you need from these three videos. Okay, and logic gate series comes to an end finally, and we have gone through so many courseworks and so many examples and all. I might put a video on questions, okay, based on the NOR and NAND based RS latch. It will be a special video. Okay, with that, logic gate series comes to an end. I'll put a post to ask you guys what we should do for the next playlist. And that's it. It has been a long time with the logic gates. I think it's time we wrap this up. So I'll meet you in the next video where we do some questions. And that's it. Thank you for watching the video on Nand based RS Latch and the final summary. If you found this video helpful, don't forget to like, share and subscribe for more lessons. I'll meet you in the next video. Until then, keep learning and stay curious.